So thank you very much to Andrew for that kind of big picture introduction. And thank you very much for the opportunity to present some of the, I guess, perhaps a little bit more left field paleoclimate research compared to, I guess, the main focus of SAFE on the Antarctica. Yeah, and I just want to acknowledge that I'm going to be referring to a bunch of work with a bunch of great people, and I just want to flag at the end, I'm looking forward to working with people as part of the SAFE community. So since the announcement of the SAFE proposal, there's one question that I get over and over again. Is like, hey, don't you work in the tropics? So why are you involved in an Antarctic project? And the answer is yes, I do work in the tropics, but the climate system is interconnected. It's interconnected in space and time. And from my point of view, I'm really looking forward to the opportunities to expand and build on the tropical research that I've been doing. And so for today, I just kind of want to, I guess from that point of view of let's see where this goes a little bit and where we can build collaborations as part of SAFE. I'm going to talk about sort of the two strongest themes of my research over the last few years. So one is I head up our Paleoclimate and Environment Research Lab at University of Wollongong. So I'll be talking about the climate reconstructions that we do as part of that. And then the other part is I'm involved co-coordinating the Past Global Changes 2K network. So that's the past 2,000 years, really focused on synthesizing climate records and pulling the data together from all sorts of sources. So for my Paleoclimate, or my PEARL is our acronym for our research lab, most recently, I've got research projects looking at the Great Barrier Reef and the climate environment ecosystem interactions there. So that would actually include sea level rise as definitely part of that story, particularly focused on the Holocene in more recent times. And then branching into the Australian monsoon dynamics and El Nino Southern Oscillation. I also have been involved in a number of science, art, science communication collaborations, and I think that's something that maybe there's opportunities there to get our science out in the wider public through not just the mainstream media, but all sorts of ways that people engage with the world. Yeah, and let's use those cultural approaches perhaps. So I just next want to go into having a look. I wanted to present to you the kinds of data that we are collecting and how that might help us when we're trying to understand what some of the climate dynamics in Antarctica, and obviously Australia in the middle of that, and the mid-latitudes too. So I'm going to focus on work we've been doing to reconstruct El Nino using corals. And I've just got a map there showing temperature anomalies in the Pacific. I'm sorry, the map doesn't quite go to Antarctica, but we are working in a range of environments, a range of locations, which means we can start looking at a range of different processes. So I don't know how familiar you all are with coral work. I think probably the closest analogue would be the ice core work, but corals, the oxygen isotope ratio and the strontium calcium ratio in corals really faithfully records El Nino or climate signals for the time that they lived in the region that they lived. The difference from ice cores is we can go into much more detail with the corals, so we can really get to that seasonal scale view and really have that little bit of a bridge. I've sort of flagged here sort of a potential link between, you know, the coral reconstructions we can do in the tropics, and then, you know, what can we do with the moss records, what can we do with the lake records from Antarctic islands within the SAFE program. The plot I've got here shows, I think illustrates the point quite well, that in the top panel there's the strontium calcium record from the coral, the middle is the oxygen isotope record, and the bottom panel is the sea surface temperature for the instrumental, in this case IGOS SST, for that grid location. And you can see that the corals are really picking up the signal in the instrumental record and picking up those El Nino events. So we can take the modern records and extend them back a few hundred years in time, so basically the lifespan of the coral. But the other thing that we've been working on in our group is picking up fossil corals. So these are corals that have died as sea level drops, or they've been washed up in storms or the like. And we can start looking back in time. So this starts to get over to those time scales that might be relevant for ice sheet changes. And I'm going to talk about some sort of hot off the press results from two really big corals that we found from the Central Pacific Ocean. That's me on the, I'm not sure if it's left or right, the 5,000-year-old 5,000 YRBP coral. That's me in the middle. So that coral is 9 meters in diameter. It's a really, it's the biggest coral I've ever seen. And yeah, 5,000 years ago, and another one that's about 1,000 years younger. And so we've gone through and reconstructed the seasonal signal in both of these, and I'm just going to present the strontium calcium record that really maps to sea surface temperature particularly. And I'm just comparing here the ENSO variants. So I've got the modern in the top and those two corals. The various lines are different thresholds for El Nino, and the take home here is a 60% or 80% reduction in El Nino variance for that these windows 5,000, 4,000 years ago. The other point here is these corals are giving us records that are a couple of centuries long, so much longer than our instrumental period. So if we compare this with some of the broader signals in some of our other proxies, and we can really start to get to the processes and the climate patterns that are occurring during these times. I'm going to take you next into a figure where instead of showing you the time series of these two different corals, just kind of stacked them up so you can see we've just picked out the El Nino years and we've just stacked them up so you can see how does an El Nino event track, 4,000 or 5,000 years ago compared to the present day, and what are some of the specifics of El Nino that we can get to. And that's what I'm showing here. So the composite paleo El Nino, basically, the pink themed sort of colors, that's really showing us. In the top one is the modern. We can see when we get down to the bottom two panels, things are just shifted a few months later, and that's the kind of level of detail we can start to get to. Okay, so what does it mean if our peaks in El Nino have changed? What does that tell us about the processes? Are we seeing just more Central Pacific or Modoki type events? On the right, again, those of you that are familiar with El Nino would know we talk about this spring persistence barrier, this difficulty in predicting El Nino events. Does that exist in these paleo El Nino events? And at least according to the data that we've been analysing, yes, it looks like it does, although it's a much more muted signal. I now just want to switch to talking about the Pages 2K work that I've been involved with. And Pages 2K, it's really the current phase. It's had a couple of phases before that I've been involved with, but to a lesser extent. It's really wanting to take our proxy records and bring them together, synthesize them. What are the common issues that we see or common patterns that we see? But also part of it is actually understanding the uncertainties in these proxies better, and again feeding that into to the modelling work and starting to do more data model comparison with this, and looking at a bit more of the modes and mechanisms. What do we see in the paleo records? What do we see in the modern records? And I've got this triangle there that kind of links all of that. In the middle are all the sub projects that are going on, of which there are a number, and I'm going to show them in our latest sort of AGU poster from last year. It's very busy, but I'm just going to focus on a couple of things. So yes, so lots of activities, lots of work looking at decadal variability, centennial scale variability over the past 2,000 years. And really there's a couple of things that I think are really relevant for SAFE that I want to bring to light. One is this bottom left-hand corner of our poster, where it's basically showing the state of play of our data sets, based both from terrestrial sources, mostly focused on temperature reconstructions, and then most recently the work of the ISO2K sub-project, pulling together the hydroclimate, the oxygen isotope hydroclimate records. And we have the ice cores represented, but in both situations we're really skewed towards the northern hemisphere, and I think there's a real opportunity within the SAFE program to fill that gap between the ice cores and those southern hemisphere, southern ocean locations. So I'm very excited to be able to help out, and I think, you know, this is something, Sharon, with the mosses, I think we could really kick into. The other one is the data model integration, and I'm not going to go into the details of this image at all, just to show that we can start getting to the detail of what's missing in our models, what are our models getting right compared to the data, what are our models, where do we need to improve them. And when we're starting to get down to the level of this sort of detail, seasonal scale or decadal scale, I think really that's kind of the next frontier. And along with the hydroclimate, I think that's another really big area that hopefully we're going to be able to contribute to. So yeah, just to sum up, I'm not sure how I'm doing for time at all, but probably I've raced through too quickly, but that leaves plenty of time for questions. Yeah, so I think there's an opportunity to look at seasonal, interannual, centennial, and potentially even millennial scale variability across the Southern Hemisphere. We can hopefully fill in some of those key data gaps, particularly for the Southern Hemisphere. Hydroclimate is, I think, going to be the next sort of, when we're looking at that centennial, decadal on higher resolution scale. Yeah, chance to do some data model comparisons. What can we do there? How can we pull this together? And then I guess as Andrew also flagged, there's a possibility to contribute to the need, you know, to the contributions to conserving these unique environments by understanding those climate, environment, ecosystem interactions. And I'm sure there's lots of other opportunities that I haven't thought about yet, but I'm looking forward to exploring them with everyone.